Welcome everybody. Yeah, like she said, my name is Jesus. This is Victor. I am the data lead for the analytics team in Barcelona, and he's a senior data scientist. So we're going to be talking about purchasing behavior recommendations, which is a type of recommendation that we're going to be doing on the Fox website. We'll go through the, let's say, theoretical aspects of how this project was built and the more specific aspects and more technical issues Victor is going to talk about. But before that, we just want to sell a little bit the team. So we're going to talk a little bit about what the team does and how this project is part of our team and part of the effort that we're doing. After that, we'll talk about the objective of the project. We'll talk about different recommendation systems and how they work. And we will go into the technical deep dive of what this subject is before reaching conclusions. Let me just get started with what we do. So I'm going to go rush through this a little bit because I want to go to the technical details. So we're an analytics team based in Barcelona, like we said. Our main drive here is going to be the number one point that you see. So it's basically building a data-driven organization. We do this through a lot of different efforts. We do this through measurements and measuring mostly sales data and marketing data. We do this through the automation of processes as well. So we have a lot of different jobs that run constantly to bring us data that we do analysis with, and we present KPIs to management with the data that we built. We do some predictive modeling as well. So we're working in some conversion prediction, churn prediction as well. And what we're going to focus on today is the sixth number that you see here, the prescriptive analytics. So we're doing a few things with this, some clustering projects where we take into account information, how people visit our website, and we cluster people together to see what kind of patterns they follow and try to act on this and do recommendations to the business. And the one we focus on, which is purchasing behavior recommendations. So it's a type of recommendation we're going to talk about. There are several types of recommendations that go into the Fox website. This will be one that will be live soon. It's already active and it has been built already, but it will be used in the Fox website in the near future. So moving on, the objective of this is going to be to, actually, if you move a little bit that way, thank you. And to get a set of product recommendations for each customer based on their behavior, which means their behavior and the behavior of the people or the customers around us. And when I say customer, I actually mean an account, which is an important thing to keep here. So this is actually good for us because it's the first step in terms of personalization of client offers on the website. And actually, it has a good potential for increasing cross-selling revenue, which is good for us as well. So moving on, now that we have the objective, I'm going to talk to you about a little bit the different types of recommendations that we could build. So there are some called content filtering, some called collaborative filtering. We're going to focus on the one on the left. Let me see if it works. Yes. So basically, this is what we're going to focus on. There are other, just for information, there are content filtering recommendation systems that are going to be based on the content, specifically on how a user is going to interact with a certain content. Collaborative filtering is going to use item-based or user-based, which is going to be the evaluation of each item based on the rating of the user for similar items. And here, the word that you think is more important is rating. This is going to be important in the following part, because a rating can be given explicitly or implicitly, which we will get into. And it can be given by a user to several items, or it can be given for an item from a lot of different users. So what we do actually is this one right here. It's called latent factors, where we take characteristics of items and users, and we reduce the dimensionality of the problem, which we will get to in a little bit. Then I just talked about implicit versus explicit. So explicit meaning that you're going to get information directly from a customer who is going to tell you, I like this item. And the other word that is important here is like. And we're trying to measure how do we know if a customer that we have in front of us likes what they're going to purchase or has an explicit preference for that. For example, for Netflix, that would be something where somebody gives 5 stars for a movie, which is something that is an explicit feedback. And you can tell this person likes this because they told us. Implicitly, we can actually do this as well, but we have to do it differently. So we have to either measure the way that they interact with the website, or measure how much they purchase, or measure the quantity of things that they purchase. So this is going to give us an implicit information on what the recommendation could be to them. They tell us, we like this because we purchase this a lot. And we can also tell that some people that are similar to this customer actually like similar products to them as well. So we focus on this one right here. Yeah, this is taking a while. So this one, the quantity, which we recommend products that are cheap but usually purchased in packages. So important thing is quantity in terms of what we're going to do, and it's implicit as well. So we focus on what they give us in terms of their interactions with us. Now this one I really like because I think this explains the system really well. So before we dive into the very technical stuff, let me explain this one. So we have how an implicit system would work here. So you have Homer Simpson in the left, and you have Peter Griffin on the right. So let's say that Homer Simpson purchases, so implicit information, pizza and donuts. Peter Griffin as well likes the same thing. He likes pizza, he likes donuts. But Homer Simpson also likes chips. So since we have this commonality in between these two customers, we're gonna recommend this item right here to Peter Griffin. So that's how this will work. Then just for information, this is the same way that Netflix does the recommendations. So it's the same system that is being built. It's just a different use case that we're using. So I will leave you with Victor to the more technical aspects of this.
Hello, everyone. So before we start with the technical aspects, first we want to point a little bit which challenges we had with this recommendation system. And the first one, which is that's more difficult than it seems. Well, the first one in top left side of the screen, we have in Festo more than 30,000 products. So it's really difficult to deal with this amount of products. So what we did, the first analysis we did was trying to play a little bit with the different product dimensions to find which was the level of the product information we should be working with. And at the end, we decided instead of working with the products, like with the 32,000 products that we have, to work with the product series, which is the fourth dimension for products. And then we only have 1,000 products to deal with. Also, we have a similar problem with the amount of customers we have. We have more than 90,000 active customers with really different characteristics, really different purchasing behaviors. So we decided to split the problem in 5 different problems and to separate those customers according to their industry segment. So another problem we have is that we are a global company, but it's part of the world has a lot of specificities regarding the type of products they purchase. So we do some, let's say, local analysis to find the best article inside each of the categories we are recommending to at least assess a little bit better the customer inside each cluster. We also try to include some additional business logic. So machine learning is fine, it's nice, but it's not everything. So we try to promote also other products, despite they haven't been yet purchased, with some additional business logic. For example, we promote SP 2020 products, even they don't have that amount of, like a big amount of purchases yet. And we also find alternative recommendations for phase-out products. So even our model tells that we have to recommend a phase-out product. We are not going to recommend that. We are going to recommend an alternative. And finally, this is a problem with a high dimensionality. We have in the user item matrix, we have more than 92 million parameters, and it's a really sparse problem. And to deal with that, we decided to go with a model formulation that consists in matrix factorization. We will go later to that aspect, and we use a distributed computed algorithm to estimate the model. So how do we land that? So let me read the 3 dots there, because it's like the most important part. So first, we recommend to a customer 3 new product series that were purchasing during the last 6 months by other customers of the same industry segment and with similar purchasing behavior. That would be the summary. A little bit difficult maybe to deal with. So let's start small. What does a product series is, when we consider a product series is new, so we consider a product series is new when the customer hasn't purchased that product series or any other product series of the same product family. So if the customer is buying any compact cylinder, which that's the product family, we are not going to recommend any of the product series inside the compact cylinder, like ADN or let me find the name, DZ8, or any other product series of this compact cylinders product family. And finally, and as we are doing recommendations for Fox, we need specific articles there. And then we need to find for each of the product series that we recommend one specific article. And for that, we use the cluster information and the most popular article inside that cluster. That's an example of how an input-output will be. So in the left side, we have an example of the input. So for example, this customer was purchasing like many different, so PD2, PD3, PD4, that's product dimension 2, product dimension 3, product dimension 4, different products dimension levels. And well, we can see he's buying like a lot of like many different stuff. And then that's what the model in the right side of the screen, that's what the model will recommend. In this case, the model is recommending mostly motors because he is purchasing everything related with motors, but no motors. So that's what we would be recommending here. And now let's go to the technical approach. So the objective, well, let R be the user item matrix that contains the ratings that our users have with our items. So that would be the rating matrix. Okay, so the red dots, the objective is to estimate numbers, ratings for those red dots. Once we estimate those numbers, then we will select top 3 higher estimations that we did for those red points to select those 3 items for each customer. So the objective is to estimate those missing numbers. And for that, we do what it's called, the model formulation is a matrix factorization model that basically consists in splitting in the rating matrix as a product of 2 different matrices, the user matrix and the item matrix. So one parameter of this modeling is the rank of this matrix factorization technique. In this case, the rank is 2, but that's one parameter that can be chosen in the model. So the mathematical problem to solve is given a specific k, which means a specific rank, then minimize this cost function that is there with a regularization term to avoid overfitting with some items or with some users. So as I was saying, given a specific k and a specific rank, let's minimize the cost function. And for doing that, we use what it's called the alternating least squares method, which basically is like this split, this cost function can be broken down into 2 different cost functions, those that are here, and those can be solved independently. That means that each step of the algorithm can be computed in parallel, as it can be split in 2. And well, for computing that, for implementing that, we estimate that with Amazon SageMaker. We use the library from PySpark that is inside Amazon SageMaker, and we use this function that it's called ALS, which is alternating least squares. And yeah, so the procedure will be given a specific rank, and we will repeat that same process for each different rank that we are testing. We split the known ratings in train and test. We estimate the model with train, and we evaluate on test. And then we repeat that 5 times, and we average the results. And the idea of that is trying to do a proxy of cross-validation, because cross-validation cannot be implemented as purely in other machine learning models. So I was saying that we estimate with train and we evaluate on test, but I didn't say how we evaluate that. And we use recall metric. What's recall? Recall measures the percentage of top K rated products that are recommended by the model. So for me to understand it easily is of the amount of things we know the users are rating and that they are purchasing, how much of them are we recommending to them? That would be a little bit an easier explanation. And here we have some example of it. So let's say, for example, user 1 rated 3 products in test, A, B, and C, and the model recommends A, B, and D. That would mean that we are recommending him 2 items that we know that he's purchasing over 3 that he purchased. And the same for the second case, but we only are recommending 1 that he purchased. And in the last case, this is a little bit different because the user only purchased 2 different products. So even we recommend 3, the maximum that we are gonna let's say, find, it's 2. So that's why in that case, recall 3, it's still 2/2, so 100% of recall. And that leads me to that amazing question, which is, okay, why don't you evaluate with precision, which is like, let's say, the most common metric that it's used in machine learning in general, if we can say that. So basically, for the third example, so if we decide to go with precision, what will happen is that for the third case, that we are finding 100% of the things that can be recommended are recommended by the model, we still will have a precision of 66%. So it makes no sense for the problem we have to deal with to use precision, as not all the customers are purchasing 3 different extra categories. And finally, that's a little bit of the results of the modeling. So we tried different ranks, and then we compute the average recall of each of the different ranks that we tried. And then we find that with 150 is the best recall. So it's the rank we selected for our model. And just as a curious fact, it takes around 2 hours to estimate that model in the virtual machine we are using. And that would be it from the technical perspective. So main conclusions about that. We showed, so we implemented our PBR, we tested, and then we showed those recommendations to the sales engineers. So we were showing them, hey, that's your customer, we would recommend him that. What do you think? And the first thing they said, which was something we were not expecting, was like, hey, you are recommending him what he's purchasing to our competitors. So that was like, okay, then we're recommending what makes sense. The second thing is that this modeling works better, like these predictions, they work better with accounts, with customers that purchase not many things. Let's say if you are purchasing a lot of different product families, it's difficult to find a new product family that suits you, as you are already purchasing a lot of things. So I think this model, well, we think this model makes more sense for smart customers than for strategic customers. A good thing also, the third point, we can promote the products despite they haven't been purchasing yet. And also we could work with different product series alternative for its cluster if that was needed, but that we will leave that for a second version of this modeling. And finally, a problem we have is that we work with product level information, so with different dimensions, that is not always as, let's say, a standard as we would need. So sometimes it makes more sense instead of checking the product family to check the product category and things like that. And as we are not product experts, sometimes it's a little bit difficult for us to deal with that. But well, that's something we would also like to improve for the next version of the purchasing behavior recommendation system. And that would be it, at least for now. So any question you have?